In this video I am going to teach you the transient analysis problem, and for that I have taken a question from previous year GATE exam, and the question can be read as in the figure shown the capacitor is initially uncharged. Which one of the following expression describes the current IT for t greater than 0? Okay, now we have the question. This is simple RC circuit, and the options are as below. This is the part of the current, and here we have the time constant. The two things that we have to find: first of all we have to find the time constant, and then we have to derive the transient current value. What will be the current instantaneous current value? Okay, so to tackle this type of problems, generally what the approach used to be, most of the students do what to find out the voltage across capacitor, and then after find out the current across this resistance wherever it has been asked. I will follow a different approach here, and that approach can minimize your time, the calculation of the time. So what I have done, in the general form, in any branch, whether we have to find, like here in this question, whether you have to find the current in this branch, voltage across this branch, voltage across this, whatever it is, in any branch if we have to find current or voltage, we will directly use this expression: IT equals to A plus B exponential minus T by 2. In each and every branch of for transient analysis, either it is RL circuit or it is RC circuit, in both of the circuits we can use this expression in any branch. Okay, now what is this? Here the A and B are constant that we will find using t equals to 0 and t equals to infinity values of current, and tau is just time constant, as we all know. And for RC circuit, tau equals to RC. Sometimes there may be so many resistance, so many capacitance. So what we will find out? We will find out R equivalent into C equivalent. And similar way for RL circuit, tau equals to L by R. So if there will be multiple L and R, then we will use L equivalent divided by R equivalent. So here we start. First of all, we will find the time constant for the given circuit. Now we have this circuit. There are two resistance values and one capacitance. So what we will do, we will find out the equivalent resistance across this capacitor. So I have short circuited the voltage source, short circuited. So here we will find R equivalent in this region. We will find R equivalent. So what will be this is the parallel connection, and we can easily find out R equivalent into C. R equivalent will be just the parallel combination of these two resistance value, and we will multiply with this capacitor. So the final expression comes as 2 by 3 milliseconds. So half of the portion is completed. Tau equals to 2 by 3 millisecond. Now come to the next part, where we have to find the instantaneous current value. Again, we have written the expression as A plus B exponential minus T by tau. Already we have find out, and now come to the constants A and B that we have to find. Start from the question. The question is like this. Again, I have drawn this. So at t equals to 0, first of all we will analyze the circuit. At t equals to 0, what happens to the circuit? The capacitor behaves as a short circuit, or you can say there is a 0 voltage drop, because initially it is uncharged. There is a 0 voltage drop across the capacitor, so it can be treated as short circuit. So here we can see this is 0 volt, it means it is short circuit, and so there is no voltage drop across this, and therefore there will be no current flow in the resistance. So I will be 0. At t equals to 0, we have I equals to 0. So in this equation, when we will put here I equals to 0 for time equals to 0, so time is 0, then it comes 1, and A plus B will become 0. So we have one equation, A plus B equals to 0. Again, when time equals to infinity, we analyze the circuit. Capacitor is fully charged. Capacitor fully charged means it behaves as open capacitor or open circuit. We know very well that when capacitor is fully charged, it will behave as open circuit, and when it will behave as open circuit, here we can see it will behave as open circuit. So we can easily find out the voltage across this terminal by voltage dividing rule, and here we have 10 by 3 volt Vc infinity, 5 into 2 divided by the sum of these two resistance values. So 10 by 3 volt is the final voltage across the capacitor, and if we have find out the voltage across the capacitor, then the current through the resistance can be easily found out, and I infinity equals to Vc infinity divided by R2. The voltage across this resistance is Vc infinity, means 10 by 3, this will be divided by 2, so the expression comes 5 by 3 milliampere. This is the final value of the current. So here we have already found out a plus b equals to 0. Again, from here in this equation, by putting infinity in this equation, 5 by 3 equals to infinity. When it comes to infinity, it becomes 0, so a equals to 5 by 3. So a equals to 5 by 3 we have, a equals to 5 by 3 we have, and by using this a plus b equals to 0, we can easily find out b equals to minus 5 by 3. Hence, putting both the constant values in the expression, we can find out 5 by 3 minus 5 by 3 exponential minus t by 2. By taking 5 by 3 as common, 1 minus exponential minus t by 2. This is the final expression of the current. So we have now the result of the given question, and we can match easily to the options. Tau we had find out 2 by 3 millisecond, and it equals to 5 by 3, 1 minus exponential minus t by tau. So this combination is the correct. This is the correct answer. In this way we can solve any type of transient problems, either it is RC circuit or it is RL circuit. In the coming days I will come with some more videos. Thank you for watching.